So here we have the final video about seafloor spreading, volcanoes, and earthquakes. So if you follow along in your notes, you'll see that seafloor spreading is the process that continually adds new material to the ocean floor while pushing older rocks away from the ridge. This always happens at a divergent boundary. And typically it happens under Earth's oceans. So the oceans still rest on top of the crust, which allows this new magma that comes up to cool, like in this area here, and the older stuff pushes out to the sides. So seafloor spreading again happens along these kind of ridges here. This is what we call mid-ocean ridges along the sides here. And as they gradually go out, they change magnetic polarity. So the ocean floor moves like a conveyor belt that carries new continents with it. New ocean floor forms along cracks in the ocean's crust as molten material erupts from the Earth's mantle that spreads out, pushes older rocks to the sides, and new ocean floor is always added. And I say new because it's being cooled again, but it was already melted rock that's already been recycled. So don't forget that subduction is when one part sinks under another and the plates are pushed back into the mantle. Here you see again how this might spread out. So this is kind of happening for us in the middle of the Atlantic Ocean, and we're getting farther and farther away from Europe and closer to Asia. Here's a video for you to watch. So if we're talking about how plates move, we know that tectonic plates are controlled by convection currents. Okay? And convection currents, just like we see water boil or lava lamps work, we see convection currents that pull along the sides. And as they move, this motion pulls the plates away from each other. And this is all heated up by the core. So here right now in your notes, you're going to explain how new crust is formed. Make sure you try to use as many of the words as you can. Subduction, convection current, asthenosphere, lithosphere, seafloor spreading, divergent boundary, and convergent boundary. I'll give you a second here to do that. You can pause the video. Now, the movement of tectonic plates is controlled by convection currents, like we talked about a minute ago. So as you see, this movement still happens, and they all move in different directions. So some slide past, which creates those earthquakes. Some run into each other, which is what creates those convergent boundary mountains, and others move apart from each other, which creates those divergent boundaries with new crust coming up. Next, we're going to talk about, you're going to fill this in right here in your notes. So right here, I want you to go ahead and describe how to do that. You need to pause, you go ahead and do that. So here's your learning check, and you're going to turn this in on Google Classroom. How is seafloor spreading producing new crust? Describe. Compare and contrast a lava lamp to the convection currents in Earth's crust, and then describe how the rock cycle and convection currents work together to create new rock or crust. So pause here and fill in the learning check on a Google Doc to turn in on Google Classroom. We're going to go ahead and move on though. So earthquakes. So earthquakes are results, and volcanoes are direct results of what happens with these boundaries. So if you go to your earthquake notes, you'll see these are all the product of constant moving of Earth's crust. So the shaking of Earth's crust is caused by a sudden release of energy at transform boundaries. Energy builds up along a fault line, and the fault is kind of like a crack in the Earth's crust or lithosphere, kind of like in Play-Doh or something like that, or a rip in paper. Once you move it, it shifts more. The crack can get bigger. The energy then travels as waves throughout the Earth. Let me go ahead and move on. So earthquakes are caused by seismic activity. Seismic is the word for that movement, or sudden stress changes in the Earth's tectonic plates at specifically transform boundaries. There are three types of faults this happens at: normal, reverse, and strike slip. And you see here just an example of how long it takes the waves to move and how they affect the crust. And you can also see in this visual right here how you can have an earthquake happen here, but the waves travel through this liquid, semi-liquid part of the Earth's asthenosphere and mantle, and that's how we know what it looks like. So there are specific parts of an earthquake. The focus is the point inside the Earth where an earthquake begins. The epicenter is the point where the waves hit the surface directly above the focus. So earthquake happens here when the two plates slide past each other, snap. And then, as a result, these waves happen along the top. So focus is where the earthquake happens on the inside, epicenter is on the outside, and it's exactly where the waves travel from. So there are several different types of earthquake waves, 3 total. The primary waves obviously are the first to happen, primary being first. And these ones compress and expand the ground. That's these P waves right here. The secondary waves move the ground up and down or side to side. And those can be really drastic and can cause a lot of damage. Then lastly, we have surface waves, which move along Earth's surface. Surface waves are slower, but they're way more destructive because they're so dramatic. So the actual crust beneath your feet buckling is what causes that shaking. So how do we know what kind of damage is caused? Well, they have 2 scales. 2 scales were created. The Richter scale, this measures the amplitude or the size of the earthquake. How big were those waves? Second, the Mercalli scale measures the destruction that was caused by the earthquake. For example, on the Richter scale, it might be a 2, but on the Mercalli scale, a 1 means no one really feels anything except for those that are really in an area to do that. We felt a while ago an earthquake that was kind of here, a 3 on the Richter scale, maybe even a 4 on the Richter scale because you could feel it indoors. It woke some of us up. My mirror was rattling at my house, but it's only a 3 on the Richter scale. Now, on the Richter scale, it actually turned out to be like a 5, but some of us didn't feel it because of how far away we were. So sometimes when this happens underwater, these earthquakes happen underwater, the result is a tsunami, which is a big wave caused by an underwater earthquake. The wave is kind of like those primary waves, just shown visually through water. At the bottom of your journal, you'll see that how you have specific differences in between the Richter scale and Mercalli scale. So let's talk about volcanoes. So volcanoes form around hotspots that release magma onto Earth's surface. This magma or lava is molten liquid rock from below the crust of Earth's surface. And volcanoes and earthquakes are always so interesting to everyone because they're so dramatic and they're so rare. First, specific to certain areas. I'm sure people in California don't think earthquakes are all that cool, but when we have one here, it's a lot more interesting because it doesn't happen as often here. So there are 2 types of eruptions. We have 1, effusive. Effusive eruptions are slow-moving liquid rock squeezing out of the surface, like you see here, kind of like a Go-Gurt. And then we have explosive. This is when magma is torn apart as it rises quickly and reaches the surface in pyroclasts, big gushes of gas and lava. Think of it like shaking up a soda can and then spraying it on someone. So we also have kind of what it looks like to have a volcano because there are several different types, but this is how it mostly looks. There's a magma chamber. This is the hot spot. The vent, the magma travels up, and then the crater where the magma either pools out or explodes out. Here's a slow time release picture of Mount St. Helens eruption. In 1 second up here, it was fine. 3 seconds later, boom, pyroclastic cloud, boom, all the way down. All that ash, soot, rock, and dust, and then lava also, as well as the gases. So the 3 types of volcanoes are composite, shield, and cinder cone. A composite volcano is created from many eruptions over and over and over, and then they pile on top of each other. And they're typically conical, so they're cone-shaped. For an example, you could use Mount St. Helens. A shield volcano is gently sloping layers of rock. An example of that would be Hawaiian Islands. The lava just oozes up over and over, creating more and more layers. And then finally, the cinder cone volcanoes are formed by explosive eruptions that leave lots of loose rock on them. An example is Wizard Island in Oregon. That's something to check out. So here are some review questions. Go ahead and complete these in the same Google Doc as you did the seafloor spreading questions. Name the 3 main layers of Earth. What is a tectonic plate? What was Pangea? What is seafloor spreading? Name the 3 different types of plate boundaries and 1 location on Earth for each one. What are earthquakes and how do they happen and how do volcanoes form? These questions should be completed on that Google Doc, and you'll prepare for your test very soon. Thanks.